From surgery to chemotherapy, from a minor scrape to open heart surgery, from a sinus infection to pneumonia or tuberculosis, even the hamburgers that you grill on a hot summer day, antibiotics are present in nearly every area of modern life and are an ever-present force for good in our world. Antibiotics are medicines that help stop infections caused by bacteria, and they can do this in multiple ways. Firstly, they can attack the bacteria's internal structures or organs, and they can attack their skin, the outer membranes and cell walls of the microbe. This video shows how the disruption of a cell wall can lead to the death of a bacteria. Antibiotics are extremely potent tools, but life always finds a way, and the rapid evolution of bacteria means they are becoming resistant, or even immune, to our most powerful antibiotics. So, how does this develop? Well, it begins with an individual cell. Every time that cell divides, and it will divide, it has a small chance of producing a resistant mutation. These resistant microbes will live amongst the other bacteria until a course of antibiotics is undertaken. That course will kill off all other bacteria that do not have the resistant genes. Once they're gone, that will leave the resistant microbes to repopulate and be effectively immune to future courses of antibiotics. We now understand how a single species of bacteria can become resistant. Horizontal gene transfer explains how this bacterial resistance to antibiotics can spread so rapidly. Plasmids containing antimicrobial resistance genes can be shared between different species of bacteria, meaning that when one species becomes resistant, it's likely that others will soon follow. There are many causes for the rapid development of antimicrobial resistance. Human practices such as overuse, not following of prescriptions, and sharing of antibiotics, the use of antibiotics in the agricultural industry on a massive scale, including in animal feed, the lack of funding for new therapeutics or alternative treatments, and the general lack of availability of information for the public sector on the correct way to use antibiotics. So we now have an understanding of antimicrobial resistance, but that poses the question, why is this a problem? Infectious disease is already a leading cause of death worldwide. Antibiotic resistance is predicted to increase these numbers dramatically, killing more people than even cancer every year. Upwards of 10 million people could die due to antibiotic-resistant bacteria. By 2050, antimicrobial resistance will be a global problem of epic proportions, with massive decreases in agricultural productivity, GDP losses up to $200 trillion, and massive increases in the cost of healthcare and treatment, not to mention the potential reemergence of diseases such as tuberculosis in the First World. Now obviously, antimicrobial resistance is a major problem, so you may be wondering what is currently being done to address it. There are 7 major categories of new therapeutics being developed as an alternative to antibiotics. The bulk of funding currently goes into research on direct-acting small molecules. These compounds are able to target new sites on bacteria, evading current resistance mechanisms, as well as being able to target both gram-negative and gram-positive species of bacteria. Potentiators are a unique class of compounds which serve to either reduce the capabilities of a bacteria to resist antimicrobial treatment, or they increase the range or activity of the antimicrobial itself. Repurposing old drugs is an efficient and cost-effective way of finding new uses for old tools that have been proven to be safe and effective in the past. Antibodies and vaccines are a well-tested and well-established mechanism for providing protection to patients against specific pathogens. Immunomodulators are compounds that work with our immune system to increase its capability to clear out bacteria and other pathogens from our system. Antivirulence approaches are being researched as a mechanism of potentially reducing the virulence or pathogenicity of a bacterial infection by targeting the virulence factors that the bacteria produce. Specifically, an example could be toxins. Inactivating a toxin that a bacteria produces during an infection could significantly reduce its ability to harm your body. And last, we come to phages of the microbiota. Phages are bacterial viruses which could be engineered specifically to target only bacteria that infect the human body. And the microbiota is the community of bacteria which live in and around and on your body at all times, modulation of which has been shown to improve immunity and prevent infection from certain pathogens. The development of these new therapeutics is absolutely essential, as the rate of antibiotic discovery has declined, and those that are discovered are rapidly made obsolete due to antibiotic resistance. The escape pathogens are the cause of the 7 most common multi-drug resistant infections in humans. They are being used in the development of many novel antimicrobial therapies. Uncle Sam wants you to avoid the use of unnecessary antibiotics. Follow your doctor's prescriptions properly. Finish off your course of antibiotics and dispose of any unused antibiotics properly. Do not share antibiotic drugs. Lastly, Uncle Sam wants you to always stay woke. And remember, only you can prevent antimicrobial resistance. Thank you for watching.